Yesterday we just talked about the shape, all right? The shape of a quantitative variable. Today we're going to do the whole shebang, which was, remember, first and foremost, context, and then socks. So we always want to start with the shape. Then we want to talk about outliers. And I'm going to put a little star on this one because it might not always be there. And we don't have to mention. If you want to write, there are no outliers, or better yet, we always have to use we call them fudge words. We call them iffy. We call them non-definitive words, are very important in statistics. In statistics, we have to understand that most of the information we don't have a definitive answer for. So you don't want to say that there isn't. We might want to say something like there does not appear to be. So it's, we're not saying concretely, and that in stats and in the grading of the exam, if you say something is, we end up not giving you credit for it. There's evidence of, or it appears. Those are the words that we want to use. And then we want to talk about center and spread. And so we're going to be focusing on these three today. We already talked about how to talk about shape, and you'll have to do that in your homeworks tonight. So it looks like oh, no, never mind. My wife had just texted me on the side about the infection rates right now, or the positivity rate. It's moved to 4.1%, which is above the 4%. So if anybody is doing in-person, is doing the hybrid model currently, it sounds like we're going to go back to fully remote for everybody. The note, that's what the news is kind of, the latest numbers are saying. So if you are a student in here that is doing hybrid and coming to school, check your informations. If you're scheduled to come in tomorrow or Friday, that might have changed. You have more individual questions that maybe I can answer, you can ask me offline. All right, so outliers. So outliers are responses that do not follow the general pattern, location, value of the data. For now, we do not have a definitive formula for identifying outliers. We're going to use the eyeball test. But because of the eyeball test, whoa, what are you doing? Get back there. Because we're using the eyeball test, I guess I can zoom in. That's pretty cool. I'll learn how to do that later on. Because we're using, oh, it's a little plus button, isn't it? Ooh, that's pretty cool. Sorry, I get amused. We say that there are potential or apparent, there's not 3 P's, outliers. Do not be definitive. Do not say that there is an outlier. We say that there appears to be an outlier. an outlier can be seen in the graph of the distribution by a large gap. And now what defines large is typically, there's no concrete in regards to it, but if we're looking at some data, for example, and we have the here, and then here. Are there outliers on here? Would you say that there's an outlier?
Yes.
Okay, and I'm assuming you want to say right here, right?
Yeah.
But if I look at the overall, this gap right here probably isn't enough to definitively say that that's an outlier. If there was another one, so this is a maybe an outlier.
Possible.
I'll say not likely though. It's not likely, but it's possible. It's a maybe. It's a possible outlier. But if I had another one over here, this is almost definitively. This is or definitive. I don't even question that one. This is an outlier. It's not even a maybe one. It's an outlier if it's that far away. So when you're looking at something and you're describing it, I would not describe this as an outlier. I would describe that as a potential outlier. Okay. It could be an outlier. It could not be an outlier. But if you write down it's a potential, I say, you know what? I can see. Yeah, I can see how you would think that, and therefore, I'm not going to take you down. But if you said that this is an outlier and it turns out not to be an outlier, now I can't give you the credit. If you said it is, but over here, that's an outlier. That's a huge gap. Okay. And there could be high outliers or there could be low outliers. If possible, state the value or values and who of any outliers. So if you know who that outlier is, like in your homework, and I don't think it happens. So in your data and you're looking at it and you're saying, oh, that was Las Vegas, that had the outlier. So we would say Las Vegas had a value. Las Vegas's response of blank, blank, blank is an outlier. And that's important. Lastly, before we move on, outliers can occur from unusually high or low response or by error. All right. In other words, if we're taking a quiz or a test and everybody gets like a 30 and then there's one person who gets like 100%, that would just be, hey, that was a high response. That was a high score. There's no other. The reason is because they were just, we can talk about why they got this score, but it's not a mistake. The other one happens, but sometimes they're just a mistake. You added an extra zero. You forgot to add a zero when inputting the numbers into your graphing calculator. And it's very important that because you're going to be inputting data, not tomorrow or not tonight, but you're going to be inputting data. And when you input data and you find that there's an outlier, it's always important to look and see where that outlier is, because that outlier could be because you just inputted the information incorrectly, or because when you were gathering the responses, that person maybe didn't understand the question, and you were asking for people's heights, and everybody gave them to you in inches, and then there was one person who gave it to you in centimeters, because that's how they're used to recording heights of whatever objects it is. So sometimes, you want to make sure you got the units correctly. You always want to take a look at outliers, because usually there's some other reason behind it that we want to take a closer look at. Center. Now, I talked about center yesterday. This is the location of a typical response. So in yesterday's class, we talked about things like what would be a typical weight of a student. When we're talking about golf scores, what is a typical golf score? Now, of course, if you don't know golf and you're just trying to go it off the top of your head, that's really tough. But if I give you the data, if I give you the graph, we can talk about a little bit, we can identify what typical looks like. So when we talk about typical, if we have, if we have, see, it looks like this, okay? And the typical in this one would likely be right around here. This is where we would say it's typical. It's where that mode is. And so this value right here is about where we would say a typical response is. Because when we look at the distribution, I would probably say that this is unimodal.
Is it only more skewed?
Yep, it is skewed in which direction?
It's not a typical response, it's so more bigger.
Well, it would be that it would the shape of this one is probably, it seems to be skewed what? Skewed left. Okay, the values stretch out further to the left of that mound.
So I do wrong for the homework for yesterday.
Yeah, potentially. That's why we want to look at the solutions. So you want to look over the solutions. Okay?
Yeah, and then thank you.
All right. So the typical happens there. Now, statistical measures for center. There are two statistical measures for center. And they are what? What are the two statistical measures for center? The summary. What are the two? When I say statistical measures, I'm referring to the summary stats. Of the summary stats, what are the two statistical measures for center? We had there's 8 numbers in the summary statistics. When we talk about the word typical, you can also hear the word average, right? We think average, typical.
Is it mean and median?
Perfect. The mean and the median are both statistical measures for center. They tell me they both have in their own way of telling me center. What does a typical response look like? What does an average response look like? However, each is not always appropriate to use. So sometimes in certain situations, it's not appropriate to use. So the mean is appropriate. You can use it. It is a measure of center, but it's not appropriate, or it's only appropriate if the shape is symmetrical with no outliers. So if the shape is symmetrical with no outliers, the mean is appropriate. And should be used. Okay? The median is always appropriate. So it is always appropriate to use the median. However, if the distribution is symmetrical with no outliers, then Both of them are appropriate, in other words. So if they, unimodal and symmetric, technically uniform is symmetric, so that would also work. But if the distribution is symmetric and there are no outliers, and we're going to learn about the reason, we'll go into a little bit more in depth about why, but um, the reason is skewed data and our outliers can drastically affect the mean, because the mean is what we call a non-resistant measure. I'll actually put this in there. Is a non-resistant measure. I'll define and go into that later. And the median is resistant. When we talk about that, the basic idea is that a few bad apples shouldn't change your opinion. And it's not, bad apples meaning that a few responses, an outlier, or even something that's causing skewed, if you're resistant, it shouldn't affect your overall thought process of what a typical of what the of what the center should be. Okay. Today we're just trying to identify what it is. Spread. The spread is, I want to make sure. The spread is where most or all of the data is located. Not just the typical, but where most of the data is. Where all of a data is. All right. Can also be described as average distance from the center. But this is a little tough one. We'll talk. That's really a deeper understanding there. Statistical measures for spread. Once again, there are two. What are the two statistical measures for spread? The two other vocabulary words, actually not even two, I would say, but the key ones. What are the key statistical measures for spread?
Would it be mode and range?
Mode is not one of the values we found, and range was not one of the values we found. Of those, so let me rephrase it. Of those 8 summary statistics, of the 8 that you found in your homework 2 nights ago,
is it the interquartile range?
The interquartile range, and the other one is
standard something.
Yes, standard deviation. And I was going to be okay with you saying like SX as well, because that's what you found in your homework. Just like the top, and I'm going to put this in, and I'll talk about it a little bit more. This is non-resistant. Standard deviation is non-resistant, and IQR is resistant. Therefore, just like the mean, it is only appropriate if the distribution is symmetrical and no outliers. And if so, you should use it. Now, IQR is the primary one. This one's a little bit tricky though. You can utilize, and this is going with what was actually had just been said by Zena. You can utilize the range. So the range is also a measure of spread. The range is a measure of spread, but typically we utilize the IQR as our primary. Sometimes we can use both the IQ and the range. They both give us an idea of the spread there. This is a resistance value. Remember, IQR is based on Q1 and Q3. And the IQR identifies the middle 50% difference. Oftentimes when we talk about this is probably the hardest one that I have in terms of really getting across in terms of the explanation. When we're utilizing the IQR, if you state the IQR, we give you full credit, all right, because you're talking about it. But you can go further, all right. You can always go and be a little bit more explanatory, in that you can also say, well, here's the IQR, and here's the range, and here's what I had for Q1 and Q3, or here's what Q1 and Q3 are. All of that information really gives you a beautiful picture of what's going on with the data. We're going to talk about it a lot more when we get into how do you graph these as we go on for the rest of the week and into next week. We're going to be focusing on what they look like in more in depth. But basically, the premise is that typically, if you just state the IQR and you find the IQR, then that's how you get full credit for identifying the spread. Shape. If it's symmetrical, I like to do a little flow chart. If it's non-symmetrical, the shape can be symmetrical or non-symmetrical. If it's non-symmetrical, then we use the 5-number summary, which means that we're going to use the median and IQR. Now, if it's symmetrical and there are no outliers, or if there are outliers, then we also use the 5-number summary. If it's symmetrical or no outliers, then we use the mean and the standard deviation. All right. I want to put a little disclaimer. Careful stating mean and median is likely to result in no credit. On AP exam scoring. And most of the stuff I'm going to be doing with you will be AP exam scoring. So if you're trying to describe the distribution and you state what the mean is and you state what the median is and only one of those was the correct one to use, what happens is what we do on the AP exam is if you give 2 responses for something and it's like, all right, let's look at the measure for center. They should have talked about the mean. Oh, they talked about the mean, yay, but they also talked about the median. The typical grading structure of the AP statistics course is that we grade the wrong answer when you give 2 parallel answers. So if you give 2 parallel answers, which means you state the mean and the median, then we don't give you any credit. Okay? So let me, so this one right here is basically it's number of days for heart attack patients, female patients with heart attack. Okay. So if this question is to describe the distribution of hospital day stays for women with a heart attack in New York, and yeah, it's just New York, in New York. So that's the question. Describe the distribution of hospital day stays for women with a heart attack. Sorry for my terrible writing. I was trying to go back and forth. I'll clean that up a little bit. With women with a heart attack in New York. It's important to note from here that these right here are the responses. And these on the top are the frequencies. Because I know I haven't given you one of them yet. Now, in your homework, I might just give you the histogram all by itself. Typically, I'll give you a histogram. I'll give you some visual of the shape so that we can see if the shape is skewed left or skewed right or symmetrical or if there's outliers. So when we answer this question, now note that you are not given the actual mean or median, or you're not given any of the summary statistics. So you do not have any summary statistics in this problem. Because we do not have any summary statistics, we're just going to eyeball from our graph. All right? If I had them, I replace my eyeball values with the actual values, mean, median, standard deviation, or so forth. So I would start off my answer by saying the distribution of hospital day stays for women with a heart attack. Why did I rewrite this question? Why did I write that? Can anybody tell me? Why did I just rewrite the question?
You had to write heart attack.
I wanted context. So I need to know I need to know that I'm talking about. So my variable here is hospital day stays. So this is my what right in here. So I've identified my what, and I've identified my who right there. Okay. The variable is hospital day stays, the number of hospital day stays. The who are the women with a heart attack in New York. Is, okay, now we're going to talk about the shape. What do we say about the shape? This one's a little tricky because there's that one bar that goes really high, but I think we can kind of, I know some of you might want to say bimodal, and I think you would be okay. I think you would be okay. But I'd probably say, what?
Unimodal skewed to the left.
So I would go with bimodal, but you can also say unimodal. They would both be okay. Okay. Yeah, I was gonna say I was gonna go with umodal, but I actually do go back and I look at it again. I see it as bimodal, but bimodal would have been okay. If you said unimodal on this one, I probably wouldn't have taken you any credit off. But it's bimodal and it's skewed. What is that? Skewed what?
Left.
It's quite the opposite. It's
right,
skewed.
sorry.
It's skewed right. On the AP exam, we would just be mostly probably looking for the skewed right. If you said this or this, we're not really looking for that information on this question. And the rubric, although you need to state it, this is what we would give you the credit for right there. That's skewed right. Did they say skewed right? Because we might say we'll accept unimodal and skewed right, we'll accept bimodal and skewed right. That could happen on a rubric. All right, so now since it's skewed right, it's non-symmetrical because of this piece right in here. That means I need to talk about the median in IQR if given. But do I know the median in IQR?
We can eyeball it.
Yeah, we have to eyeball them. So we'll instead of saying the word median, instead of saying the words IQR, we'll just use the words typical and between. Most are between. So in skewed right. The typical number of days is what? Where would be the typical?
Is that 7?
Is about 7. And I would probably accept, like 7 to 8 right in here is about 7. Now notice I said about. I didn't say it is 7. The typical is not 7, it's about 7. Or it's between 7 and 8. Okay, we want to use the word non-definitive whenever possible. So that's typical. And finally, most hospital stays are between, and now we want to look at the biggest chunk. So if I look at the biggest chunk, typically it seems to be right between here, and it seems to be right around in here. Most hospital stays are between So where is the most? Where's that big chunk?
About 5 to 13 days.
Yeah, I would actually back off to 4, but 4 to 5. I would go to 4 if you said 5. That's okay. To around, I would agree 13. If you said something like 12, that's okay as well. As long as you're not saying to say like 25, that's the big ones. Days. Most of my responses seem to be right around that area. It kind of gives you an idea of how spread apart. So most people are staying between 4 and 13 days. Okay, most people are staying somewhere between 4 and 13 days. And a typical day stay, if you had a report to somebody who had a heart attack, how long they should expect to stay, they probably should expect to stay around 7 days. Now, that doesn't mean they're going to stay 7 days. Most likely somewhere between 4 and 13 days. So you might see on the things, you might stay usually between 4 and 13. But that doesn't mean you're going to stay between 4 and 13 days. You might spend even one day, you might spend, and in terms of this data, what does it look like? 36? And in all, you could want to say all stays are between 1 and, I believe that appears, I can't actually see it. Yeah, 1 in 36. Now this information here is helpful, but it's not a required statement in here. So far, what you can tell is somebody who just had a woman who had a heart attack in New York City is She's going to stay at least 1 day. But she shouldn't expect to stay over 36 days at all. I mean, that's like the extreme, but it's not that. I wouldn't even go further to say that's an outlier here. But in terms of expecting somewhere between 4 to 13 days, plan for 7 days. So if they had to get clothing, they probably should bring clothing for 7 days. But they should understand that they may stay a little bit shorter, they might stay a little bit longer, or in some instances, very short or very long is a possibility. That's what we had to think about when we're talking about this ascribing the distributions. We want to paint a good picture. All right, it's bimodal because there also is a bimodal in the sense that there's also, when I said right here, the typical day is about 7 days. Because I said the word bimodal, I would also want to add to give him a better answer, and 1. All right, because there's a peak around 1 day, and there's also a peak around 7 days. So most, if you might just say there's a lot of people who are staying around 1 day, but then there's a group there's a group around of stays around 7. So they might typically they might stay for 1 or 7 days, but that doesn't mean they're going to stay 1 or 7. And that's a big thing of understanding. It could be 4 to 13. I know this sounds tricky at first. I know it's a new way of thinking. It's a route of describing. But if you think about how this information can be presented to somebody, you're a female, you just had a heart attack. What should you expect to stay? Okay, well, bimodal distribution of stays. So it seems to be a peak around 1 day and 7 days. As where most people are a typical stay is 1 or the other. However, most hospital day stays are between 4 and 13 days. From our data, we've had all of our stays land somewhere between 1 and 36 days. That really paints the picture in terms of your planning, and that's what we're trying to do. We're trying to take just this graph right here and be able to pull out all of that information. Your homework is a handout.